Hi, we are GP53. In this presentation, we're going to cover our project for SC4000 machine learning. As you know, LLMs are very popular nowadays with tools like ChatGPT and DeepSeek becoming integral parts of our daily lives. So in this project, we're going to answer one core question. Given that we have two responses, response A and response B from two different large language models, which one would the human prefer? This is a multi-class classification problems, and we're going to evaluate the performance by using log loss, which means the lower the score, the better. Before we go into the implementation, we would like to discuss our research question in depth. So first is that given the nature of prompts and responses, they are in natural language, which is good for human understanding, but bad for machine interpretation. Next is the subjectiveness of human preferences. So as you know, there's no common standard or absolute metrics for measuring the human preference, and the human themselves are very unstable. So this will be a challenge for us. And we also have an issue with the class imbalance among our data, which whereby we have an uneven distribution of the three results. Next is that our training data is not explicitly labeled what the good response is. And in our model learning, we're going to go through the responses and the human preference, and the model will learn that response, uh, which kind of a response would human prefer. We also face issues on computational constraints, whereby we are running this implementation on Kaggle environment with a T4 GPU and under a limited time. Then also given the context of our LLM, our implementation should not only perform well on the training data, but also generalize well when we are giving it unseen before prompts and responses. So this is our approach to the research question. Responding to the challenges in the previous slide, we'll first do the data processing and augmentation. Then we're going to do the semantic embedding extraction and comprehensive feature engineering. And lastly, ensemble model training. In data processing stage, first we did prompt passing, which we convert the JSONs uh, conversations into strings. Then we did the data cleaning. We removed the 35 invalid training samples. And one key thing we did is the swap augmentation. It duplicates each sample by swapping the response A and B and inverting the winner label. This in turn gives us double the training sample. And this is actually very good for our training outcome, which we'll show later. In the next step, we choose to use MPNet as our feature generator. It is very good at creating semantic embeddings that convert natural language sentences into fixed length, dense vectors that represents meanings. So as an output of our MPNet, we get very useful features like cosine similarities, L2 distances, text statistical features, and interaction features like dot products. With these features, right, the in turn we can feed them into the machine learning models, and we chose three gradient boosting machine learning models to train each class of our outcomes: winner A, winner B, and winner tie, with five-fold clause validation. We then use an ensemble weight optimizer to find the best blend coefficients of the three models to minimize the log losses. Let's move on to the next part. We have used many techniques in this project, not for fun or by coincidence, but as a result of our tireless effort to push for the best performance. In this section, we'll explain why we did what we did. So first is the embedding. We actually did a comparisons between the different models and found that our MPNet 768D performs the best, having the lowest score among the three, which is the best. And it has a very good trade-off between the accuracy of the model and the computation resource and time it needs. Next, why did we choose to ensemble the three gradient boosting model? Again, it is because we did the comparisons and an experiment on it. So the ensemble, as a result, the ensemble was 0.34% better than the best performing single model, which is cat boost. So, so with the ensemble model, we are gaining from the combined different algorithm strengths, and which this model captures the diversity um, with a better pattern and leads to a more stable and robust final prediction. In experiment 3, we evaluate the contribution between the embedding and statistical features. So in the first uh, experiment, we did a comparisons with embedding only, statistical only, and combined. Realized that statistical alone, statistical features alone is very weak. It does not improve the performance. But when we do our further research and study, we found out that instead of using the 33 basic set of statistical features, if we expand it with an enhanced set of 49 features, that which includes like polynomial transformers and interaction terms, right? Then we are able to achieve a much better performance of improvement of 0.15%. So in the end, our final choice is we use a combined model of the embedding and the statistical features, which comprises of 49 different features. In experiment 4, we compare the cross validation folds, and we see which fold give us the best score with the acceptable standard deviation. What we found out is that 5 folds give us the best performance with a slightly higher variance, but it's still acceptable. So that's what we use for our training. And in the last experiment, we demonstrated a tremendous improvement brought about by our response swapping. This not only brings the biggest improvement of 2.4% to our performance, but it also doubles our data and reduces our chance of overfitting. It also resolves the issue of a position fixed and teaches the model to be more symmetry, making the model to be more symmetry, bringing a big gain. So as a summary, these are the techniques we use to inch towards a better score and a higher competition ranking. Using a combination of this, our best score is 1.1 in the public leadership board, giving us a relative ranking of 64% in this Kaggle competition. All right, that's all. Thank you.